Hi, everyone. Welcome to Foresight's Intelligent Cooperation Group. As a preamble to this meeting, we split today's keynote, which originally had 4 presenters, into individual different keynotes, because I think the ideas are really amazing and everyone really deserves a little bit more time to be discussed. So future invitations are to follow. We also released a new chapter draft, and that's focusing on cooperating with AIs and how to incorporate AIs into our framework of voluntary cooperation. And so to bring you up to speed, we started the entire book, ideally, and initially with identifying voluntary cooperation as the main driver of civilization. We then explored crypto-commerce tools for facilitating better human-to-human cooperation. And now we take the next leap, finally, for discussing how to bind AIs into the mix. And in the chapter, at least, we start by really showing parallels between the common threat of an AGI singleton that takes over the world and the threat of previously centralized systems that had the ability to take over the world. And learning from those lessons, we propose that instead of trying to design a novel, single, super intelligent agent that can follow human values, we should try to create a diversity of decentralized instantiations of super intelligences that can be incorporated into our existing framework of voluntary cooperation. We also review a few promising approaches for how to do this. And we start with principal-agent relationships across entities that want to cooperate. And whether those entities are humans or AIs, a principal always has a variety of different ways to align an agent with its request. So when thinking about what is needed to align AIs with human principal requests, we can already learn from the tools that human principals already use when cooperating with other human agents. And today we'll hear about incomplete contracting for human cooperation and what it would take to extend this to cooperating with AIs. And today we're super happy to have Gillian Hadfield here from the University of Toronto. She has a lot of different titles that I will post here in the chat. But inter alia, she wrote a fantastic book on rules for a flat world, why humans invented law and how to reinvent it for a complex global economy. She also published a fantastic paper on incomplete contracting and AI alignment that I will share here as well. And we already had the pleasure of welcoming Gillian previously for a Foresight in-person meeting for our annual member gathering. And so I will share some info on that too. But for now, she will start with 10 minutes or 15 minutes on this framework. I will then start with a few questions, and then we can't wait to hear from you. Please start collecting your questions or comments in the chat, and then we'll just hopefully have a really nice go around. Also, just a shout out, Joscha Bach, because I see you here. Well done for getting on Lex Friedman's podcast twice. Okay, sorry, I couldn't help it. Gillian, now it's up to you. Welcome to this group.
All right. Thanks, Allison. And I'm really looking forward to this. Allison gave me a sneak peek of the questions that she's going to ask. And I think this is the best set of questions that anybody's given me to talk about this stuff. So I'm really looking forward to getting to that conversation. And I am going to hopefully go through you really quite quickly, 10 minutes maybe at most, so we can get to the concept here. So Allison led in with, the framework. I think is so critical. First of all, I think, the concept of decentralized multiple AIs and how they integrate into our normative systems. That's absolutely critical for us to be thinking about. And I think it's the most important thing for us to be doing. We should really be trying to figure out how do we embed a particular set of values into AI systems. We're thinking about how do we embed them into our complex structures for aligning other humans, because we now need to expand that to include AI entities. So I'm going to talk a bit about incomplete contracting. Allison mentioned that this is actually a paper. This is from a paper with my son, Gillian Hadfield. So if we want to think about how do we get an agent to do what we want, right? That's the puzzle. Well, we've been studying this in economics for quite some time when we're talking about human agents. This is the theory of incentive. And when we started down this pathway as economists, thinking about how do we give agents the incentives to perform in the ways preferred by the principal, and that are ways that are aligned with the principal's interests and goals, we developed concepts of contracting, economic theory about contracting, and the idea that, well, you can write a complete contingent contract. You can get the agent to do what you want if you can write a complete contingent contract on all the observable states of the world that matter for payoff. So that's our theory of incentives. But after building some absolutely gorgeous, elegant models, beginning around in the mid 80s, which I will confess is when I was a graduate student at Stanford, thinking about these things, um, we started to recognize, and Alden Williamson was sort of a lead on this, that contracts were not generally complete. It was actually, when we looked around at the real world of contracts, a lot of those contracts are incomplete. To roll another Nobel Prize winner in economics, almost every economist would agree, he said in 1999, that actual contracts are or appear quite incomplete. Many contracts are vague or silent on a number of key features. And this is an absolutely important observation, and it's kind of something that has to be repeated. I'm also trained in law, and I'm a law professor, and I teach contracting. And the key thing that the disconnect between the way economists sometimes talk about contracts and the way real world of law looks like with contracts is the fact that they are replete with vague language, like we agree to behave reasonably or do what's commercially effective in this contract. We don't see crisp. We see some crisp terms like pricing terms, for example, maybe delivery dates, and some technical specifications, but there's lots of vagueness and lots of gaps. So that spurred the analysis in economics of the incomplete contract. It said, okay, since you take seriously that contracts are incomplete, we don't want to spend all our time designing complete contracts. We want to think about what's the optimal design for an incomplete contract. And because what we recognize is that incomplete contracts give rise to strategic behavior. Well, you didn't tell me I couldn't do this. I will exploit that gap. And it can lead to suboptimal behavior. So we now have significant literatures in economics that look at the analysis of incomplete contracts and the design of incomplete contracts. How can we optimally design contracts given the constraints that they will be incomplete? So now let's think about artificial intelligence, and focus in particular on the form of AI or machine learning that uses reinforcement learning. Of course, we have other approaches to machine learning, supervised learning, unsupervised learning. But in reinforcement learning, we are specifically saying, how do we establish a reward function for an agent, and now an artificial agent, to learn how to behave in an environment and achieve the goals that we as humans have for that artificial intelligence. And that's some of the powerful systems that we have out there. But this is relatively recent. This is 2018, first workshop on goal specifications for reinforcement learning. How do we get that robotic agent, that artificial agent, to do what we want? And the answer is that just like it's really, really hard to write complete contracts, we should treat it as impossible. Reward engineering is very hard. This is an illustration from another paper that Dylan is an author on, with Stuart Russell and Ankur Jagan and Peter Abeel, really looking at this problem of how do we deal with the fact that our designer of an AI system, a reinforcement learning agent, supplies a reward function, here called the proxy reward function, to the agent. The agent learns on that proxy reward function, but if there's a gap between the proxy reward function and the true reward function, we're going to get behavior that we didn't intend. So the illustration here is, you think you're training this robot to find the best route to the pot of gold, taking paved roads, taking shortcuts through grass. You then put it out into the real world and discover that there's lava pools in your environment, which you didn't think about. But of course, you have very negative utility on going through the lava, having the robot go through the lava, but you didn't say anything about it. From the robot's point of view, the lava is just fine. There's no cost associated with it. So that's a challenge of how do it's very comparable to that incomplete contracting model. So just like we have our incomplete contracts leading to strategic behavior, exploitation of gaps, and suboptimal behavior, we're also going to get that when we have misspecified reward functions. And the first lesson from incomplete contracting is to say, and you need to treat the misspecified reward function as, to some extent, unavoidable. You can't just keep going back to your engineers and wagging your finger at them and saying, get it right next time. Let's get the reward function. They're always going to be, to some extent, misspecified. So the question that we have been thinking about is, what can we learn from incomplete contract theory to better understand and more systematically find solutions to AI misalignment and misspecification? And so I'm just going to talk a little bit about one of the things that we've been exploring here. So you want to imagine here we've got our robot. The robot has got a reward function that's going to reward the robot for carrying boxes across the room. And if we train our robot in this environment, it's going to learn the best paths and efficiently learn how to get those boxes to the other side of the room. But if we then have unexpectedly, let's say, a vase appears in the path that the robot has developed for carrying those boxes, what is the robot going to do? Well, it's just like the lava in the last picture. It's just going to knock that vase over because its reward function doesn't say anything about knocking over vases. And if you start thinking, well, let's just make sure we get vases into the reward function, then think about cats and think about children and think about pools of oil and all the other things that might occur in a real world setting. So the robot in this setting is just with that reward function is just going to plow straight through that vase. So how do humans solve this problem? So just think, let's suppose we just hire a human and we write a contract with that human and we say, we'll pay you for same reward for carrying boxes to the other side of the room. And we announce that contract, we use that contract, and then the agents are is set loose. And again, we have a vase that appears on the human's normal path. So what's going to happen here? Well, we all know what happens is the human's going to walk around the vase and not knock it over. Maybe he or she would move the vase, but we're not going to knock that vase over. And the question is, how is it that humans know to do that? What is going on with humans that we're not behaving like the robot here? Well, the key thing that we want to talk about is the fact that human contracts come embedded in an environment, an institutional, structural environment that has lots of capacity to help fill in terms, interpret terms, and determine what was the appropriate behavior in a particular setting. So we have implied terms and institutions. So again, teaching contracts. What was it reasonable to think the parties had in mind when they agreed with respect to vases? They didn't say anything about it, but what would they have had in mind? What would they have said? We have an elaborate structure of legal reasoning as well as institutions that can implement that reasoning, including legal advice, not just adjudication, to say what's the reasonable behavior for that setting. And what that means is that we have these external institutions. They might be formal institutions like courts. They might be informal institutions, just like reputation in groups. And those are filling in the contract, which formally, expressly just says you get paid R for carrying boxes. But those institutions are filling in that gap and say, well, no, there's a cost associated with knocking over vases. You might get a bad reputation as an employee and you're not going to get a good reference for your next job. You might get sued by the employer, or you might have money withheld from your paycheck. And those external institutions are filling in that contract, filling in the incentive for the, and this is what makes it rational for principals to enter into these contracts that everybody knows are incomplete. They say, well, a lot of the gaps will be filled in. One of the ways to think about what's happening here is that our human agent, when that vase appears, goes through a process of thinking about what would observers think if I just plow through. I've got a choice. The vase is in the way. But what would observers think if I just plowed ahead and walked through that vase, knocked it over? And Adam Smith has this wonderful concept of the impartial spectator. This is from theory of moral sentiment. So I think really captures this idea, the idea that we have he was thinking about this as a description of morality and moral conduct, that we are kind of constantly engaged in this hypothetical reasoning what would a neutral and impartial observer think about my behavior if I behaved in this way? So what would the impartial spectator? And as we still in institutions, it could be what would my impartial spectator think? What would a judge think? What would another employer think? What would a coworker think if I behaved that way? And that's how humans are filling in those incomplete contracts. So the question that I want to explore, and I'm looking forward to our conversation, is how can we build the normative infrastructure that could support AI alignment? Because I think a key message I always want to give to people who are working on the building and design of AI systems is where there's a lot of game theory. Game theory is great. There's lots of game theory, but it basically assumes we can solve the problem inside the box. Or there's the math, there's the design of the reward. There's the idea that we can fine tune the math of those reward functions. And I think the key thing we're missing is the idea we need this normative infrastructure. Human societies would not work without that normative infrastructure to help support those incomplete contracts. We're going to have incomplete reward specification and goal specification for AI. So how are we going to build that normative infrastructure to support AI alignment? And Alton, how about if I stop there and then we can jump into conversation?
That sounds lovely. Thank you so much. Very crisp. And I can't believe that you actually were able to condense this paper so succinctly. Thanks a lot. Maybe I already have a question from Kate here and one, maybe a comment from David in the chat. I'll start maybe with 2 or 3 questions at the beginning. And maybe we can still keep them recorded in case and then we'll move to an off the record discussion so that we can have a little bit more of a free flowing back and forth. But, you're mentioning the partial observer, and I'm really interested in what do you think are the most important differences across human cognition and AI cognition that could become difficult when transferring the incomplete contracting framework from humans to AIs? Because what would it really take for an AI to predict a community's like normative structure? Humans have really evolved for this impartial observer. AIs haven't really. And so how would we be able to actually transfer that framework to to AI cognition?
Yeah, it's great, 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 great. So I think the key point here is I absolutely do believe we have cognitive architecture that humans have evolved that is attuned to what would others think? We're predicting what would be the response of the community. We think a lot about when we think about morality. So I spend a lot of time now with groups looking at um, morality in AI settings and think about that. But there's a big focus on the compliance, right? Like what's our cognitive? So we have ideas that humans have a preference for complying with rules and so on, which I resist because I think that's kind of it's a cheat. It's kind of slapped on. It doesn't really tell us what's happening. And I think what's really distinctive about human societies is the third party punishment schemes we have. And punishment is a powerful word, but it could just be a raised eyebrow, right? That tells us, like right now we're looking at each other over a screen, we're interacting on chat, we're raising hands and so on. There's all kinds of norms right in here where we're kind of like also being conditioned by what do you think is the right thing? Should I just keep talking? Have I been talking too long? Right? Should I bring it to a close here? I think we have developed the cognitive architecture to constantly engage in predicting how would third parties respond from formal third parties all the way through formal institutions. So what does that mean for AI systems? Well, in a way, it shouldn't. I mean, I'm not saying it's easy to build them like that, but conceptually, it's not difficult. Conceptually, it's the same challenge. How do you train your systems to not just make predictions about what will happen if I pick up the cup like this, or if I turn the wheel on the car like that in physical space? How do I predict normative space? And the thing that I see about the way we train our systems right now is we're not providing that information. We're basically like training our large language models, we're training our autonomous vehicles with none of the support structure that humans use to figure out how to do it, which is draws heavily on predicting those third party reactions. So I think we need to think about enriching the information, the data on which we're training in that sense. So I think we can build that comparable cognitive architecture for AI.
Okay, even if we could, do you think that, that will be, I guess, the more prevalent way that effective AI systems will be built? Because one could also imagine the opposite scenario. So instead of humans aligning AI agents with our interests by teaching them to develop internal spectator, maybe we lose our own internal spectator over time, because the more we cooperate with artificial agents who naturally follow more of a homo economicus cooperation style, that makes them more superior players, the more we lose our own ability to potentially have an eternal spectator. So, like, just because of the fact that by them just going along with the homo economicus setting, but by being pretty unbound in their ability to fake, they may be more effective at cooperating, and so they may just supervene in that regard.
Yeah, no, this is a really fascinating question, and it reflects the kind of thing I do worry about when I think about. I mean, I've been emphasizing how do we integrate AI into our human normative structures, and that means we got to build for them to integrate. And I think that's where our alignment solutions have to lie, because just like humans, right, the way we align is we're integrated, and that's flexible and it evolves and it changes over time and space and so on. But you're emphasizing another really key point, which is if we start having a lot of artificial agents in our midst, what does that do to these systems that we have come to depend on? And I think that's really important. I think if 50 or 75% of the cars are on the street are autonomous vehicles, right? I now have less information about the humans in my community because I used to know something about the humans in my community from the way that they drove around on the highway, right, or at the four-way stop or at the intersection. Um, and I have less information now about other humans. So I think your point about does it start to degrade our impartial spectators? Like the kids, people worry about the kids who are like talking to Alexa or Siri, and they're talking to it like it's an it, which it is. And is that degrading their interaction with humans? I don't have many answers to that except to say that I think these are the kind of existential threats that we face, that we're just going to so destabilize our human systems that we have to be very cautious about it.
Yeah, I think one, I guess more crypto-commerce tools that we mention in the book is potentially using blockchain to allow an AI agent's internal working to be transparent and observable by anyone interacting with them, and that could maybe give a bound on their ability to fake. And so reinstantiating a little bit this constraint that humans have when faking. Are there any, directions that you want to point to in promising research areas or like, currently available prototypes that people could consider when they actually try to do research in this direction?
Yeah, I don't know about prototypes, but I think what's important here is if you're zeroing in on the right dynamics, right? So this is all about trust, right? This is all about, am I willing to participate in a complex interdependent set of relationships and count on the fact that somebody else is cooking the food and somebody else has built the bridge, and right. So I think to the extent that we can be using technology, blockchain, or whatever to address that trust problem is really important. I think once you take the lid off, so I know that like Andrew Fritz at UC Berkeley, Chai has done a lot of thinking about, like, if you know if it's common knowledge what your strategies are, like can you get equilibria and what does that do that? So I think those are some interesting things. I think the thing that's tricky is once you take the lid off this, perfect transparency is not necessarily what produces trust. And so I think it's going to be more complicated than, well, we can make our AIs, if we really are saying what we want our AIs to do is to be able to act like competent humans. I think we actually depend a lot on the fact that we have all kinds of different lines we draw around what information is shared with who, when. And so my starting point might, I'm it's a great question to explore because it does address that trust, but I think it's going to be a lot richer than we maybe anticipate once we take the lid off.
Yeah, I agree. I think what we also propose is not making everything transaction, like not making everything transparent that an AI entity does, but just in certain situations you may want to introduce transparency, and in others, you want to have shielded transactions. Okay, that's enough for me. Thank you so much. Very, very eloquently answered. I will take David Mannheim next and trying to be on the record, and I'll follow up with the others what they prefer. Okay, David, you're first. And maybe say a word about your background so Gillian has an understanding of the content.
Sure. Brief word about my background. I do lots of things, including some thinking about AI alignment and how metrics are designed. Um, so specifically in that regard, I want to flag. So yes, it's true that metrics are always going to be imperfect. Like you can't completely close the gap. But I also think that um, there's a huge space between what people usually set as um, easy to operationalize goals and what it is that you could do if you try to actually um, come up with like think about what the failure modes are beforehand when you're designing a system, and that's the kind of first level of we should make sure to do that. But the second thing is I think um, you pointed out that the gap between the goals that the system has and what it is that um, uh, you want it to be doing is hard to close. The question that I have is, it seems plausible at least that um, an AI system predicting what the impartial observer would be upset about, especially if they're willing to be kind of, if you look at children of certain ages, they'll be kind of very hesitant to do things that might get them in trouble because they're not really sure what it is that they are and aren't allowed to do. And it seems like that's an easier predictive task than um, actually directly inferring what it is you're supposed to do. Um, so it seems like maybe there's something there. Does that make sense as an approach?
Yeah. Yeah. Let me just say on your first point, completely agree. We should, we should put as much in there as we can, and we should do a great a job as we can on reward engineering. So, this is not say throw it here, just to say, but we need to be thinking theoretically about the fact we're never going to fix all of it. Now, on the other, so actually, thinking about the child being cautious, not sure what will get them in trouble, is actually not a bad model, right? And that's actually what the prediction we're talking about here is, and because even though mathematically rewards and punishment are the same thing, right? What we do know is that our normative systems, our legal systems, they primarily operate on cost, on punishment, right? And I have things to say about why I think we see that. Um, but the idea is that, yeah, child is thinking, okay, what's going to get me in trouble? That produces caution. That's actually one of the principles of reward design that people like Dylan and Stuart Russell and Ankur Dragan are working on. Is the idea that actually you do want your AI to be uncertain about what is really wanted, especially in domains that are outside of the training. Like, can they recognize, hey, this wasn't in my training data. I had nothing like this in my training experience. I should be cautious. That may not be a bad principle. And it's really interesting to think about that. I hadn't thought about it with relation to it. And that's, children will be cautious in that way. I mean, at the same time, they're rushing forward, like not, they're learning this whole thing, like, oh, I could get in trouble for this. Who would have,
At certain ages, in certain situations.
right. Yeah. Yeah. For sure. Thanks.
Thank you.
All right, great. Next one up, we have Kate, who's also fine to be on the record.
Okay. My question. Oh, thank you so much, Gillian. First off, my question is about case law. So I'm not a lawyer, but it seems to me that the way in which we're able to fill in the gaps in contracts is because we have this historical record of case law that has happened in the past. And it seems to me that that's actually quite a bit like machine learning, in that we have this record of things that we've learned, and we're able to consult that to figure out what to do next. Um, and so I'm curious if we could use anything similar for AI, and what that kind of institution would look like. Would it be possible to have some kind of database of previous things that AI agents have learned, and be able to share that kind of knowledge.
That's really interesting. I mean, I think I want to emphasize that case law is an important thing in our advanced formal legal systems, but those are relatively new and recent in human evolution. And I think we've been filling in filling in the contracts for a very long time. And there's a lot of places where what we're having reference to are sort of the more informal norms, and then the data we're using is all of our experience of all the times we saw how did people react when somebody talked like that in a session or behaved that way in the restaurant or on the bus or whatever. But I do think there is something from having formal case law. And I think what's really important there too is that that's how I think David Friedman on the call too, so another law professor can talk about these things. So we have case law. Now that's a common law approach. And that's another interesting thing to look at, the difference between different systems. I wrote about this a long time ago, thinking about how these information differences between common law and some court systems led to different behavior in behavior of courts and so on. And of course, what we do in those cases, and now this is really recent, right? This is like 19th century Harvard Law School inventing the casebook approach to legal education, is we train all our lawyers on reading the same cases. So they've all read these kind of archetypal, and they've engaged in the reasoning. So it's not really even the precedent in the case that matters. It's what they've learned about engaging in this shared system of reasoning, because that's what lawyers have to do, is predict what would open lawyers think about this. So I think it's a fascinating thought to say, so what we need, because this is like my answer to Allison earlier, saying, I don't see us building the data sets that provide that kind of feedback. Like let me train GPT-3. It's just training on the internet to predict, what word is next. And what it's not training on is how did people respond when they read that on the internet, right? What did they think about it? So I do think that developing the data that you kind of want to marry up with that is to say, when you answer that 5-year-old that way, right? People said, you don't say that to a 5-year-old, or you don't use that language. You might use that language in this chat room, but you don't use it in this public news feed, or that, you say that. Anyway, so you get my point. So I think that's I really do think this is a place where we need to be starting to get creative about how would we build our training data sets. I think a massive problem we face is that we're just training on cheap data, and we're just not recognizing these are really complicated things. And so I think whether it was an adjudication type process, right? So maybe you're reviewing the way an autonomous vehicle behaves. Like, should we have community processes that are reviewing that and accumulating that information? Or is it just organic observation? How do people respond? Anyway, I think that's a really interesting thing to explore.
Awesome. Thank you. Yeah, I think we were just discussing in the chat about where could we get this data from. And maybe there's a few current decentralized arbitration crypto commerce tools where
Hey, Federico here, yes.
we could actually garner some of the data about how humans usually want to
Okay.
solve disputes or so forth. Okay, next question. We have Mika.
So this feels surprisingly similar to the problem with autonomous cars, obviously, and for two different reasons. For one, it feels like, just as with autonomous cars, humans are not 100% successful at doing the thing that we want them to do, right? So humans fail a lot, both at driving cars and just the interaction with society around them. So we don't actually have to fully solve the problem. We just have to do better than humans, which is a pretty low bar, realistically. And so, similar to autonomous cars, the bar is low. You just have to drive better than a human. And I feel like similar with AI is it's like interacting in our environment, just like in other ways, the bar is the same. Like, you just have to do better than a human. And so I feel like I definitely agree with you 100% that we cannot solve this manually. But at the same time, we also don't need to shoot for perfect, which I think is kind of there's a natural tendency to want to find a perfect solution, which is just impossible. And the second part about how this, I feel like, relates to autonomous cars is similar to how Tesla is training their data. They're basically just having the cars watch humans drive. And then the cars basically learn, what would a human do? And so any situation the car is put into, it just asks itself, what would a human do? And then it tries to do that thing. I feel like, if we can have these AI agents in our society just watching what we do all the time, and then, of course, there's questions on mass surveillance, yada, yada, yada. But if we just ignore that for a moment, we just think about, imagine these AIs could just watch everything and watch what humans do. And then at that point, now you just have to just tell them, do what that thing is doing. That those things out there, those little things walking around, talking to each other, interacting, etc. Just mirror that. Do the same thing, and it will. I suspect using that technique, we could get good enough pretty quickly, and then eventually better than humans, which is the target. And once you're better than humans, then you've succeeded, and then anything after that is just a bonus. If that makes sense.
Yeah. So, I think there's lots. So let me just, I just want to make an observation about just do better than a human, and thinking now autonomous vehicles. I think from a consequentialist point of view, we could say that, right? But we just want self-driving cars to kill fewer people than humans kill. Um, but I actually, now it's another way in which Allison's question about what happens to humans when we introduce. I actually don't say humans. So I think of our normative infrastructure as an equilibrium process, and it's really what allows us to keep working forward in complex interdependence and increasing levels of complex interdependence. So it's very much a social scientist perspective on normativity. It's not an internal perspective on what's good or bad or moral or not. It's saying it's a tool we have. Normativity is a tool we have, and these normative structures are what move us forward. So if we introduce autonomous vehicles into the mix, they're a different kind of entity, and I may not trust. When I interact with a human, I kind of, in equilibrium, I'm cutting them some slack for the mistakes they made. I don't know if I need to cut machines slack for the mistakes they make. They're not human in the way that I am. So I'm not. And I know this is a big topic in autonomous vehicle world. Well, why are people wanting more from a machine than from a human? I think it's because it's that complex process of normativity on there. But I agree with you. We don't want to set the bar to be perfect, and I think that. So that point about do what humans do, I don't know if you mean as a training mechanism. There's certainly lots of work being done on, to what extent can you train on just observing humans? Well, if you're trying to train for normative behavior, you're going to run into a lot of problems because, humans are not always implementing our, the normative rules like that. Like, I don't think I really do not believe you want to train your adjudication systems entirely on the decisions made by human judges. I think you want that to be information, but you don't just want to replicate that. Don't want to set the bar too high, but I do think that the right way of thinking about it is you want machines to be normatively competent and then to interact with humans in that way. So lots to think about there, I think.
All right. Thank you so much. Next one up, we have David Friedman.
Right. I had to unmute myself. Humans learn what we're trying to teach the machines in two different ways. One of them is hardwired by evolution, and the other is by training as children. And I'm not sure I see what are the limits to using the latter method for AI. That is, suppose what you do is you put your AI in the kind of environment it'll function in, and you have an impartial observer. You have a human being who is monitoring the process, and at each step, in effect, saying, yes, that was right. No, that was wrong. No, that was terribly wrong, and so forth. The AI then trains on that. This is going to be expensive. It's going to take a lot of human interaction, but you only have to do it once for a given environment, because you then make 1,000 copies of that AI and you load them into 1,000 robots, and now you're home free. And eventually something terrible happens and you realize you've got to have a broader environment, and you tweak the system. But I'm not sure I see what are the limits to that learning model for how you teach it to it.
Um, well, so your question sort of has is there a premise in there that I said there's a limit to that? I mean,
No, but we have a puzzle, and I'm trying to see why that is.
Yeah. Well, no, I am saying I think that training I want to disagree with one thing in the model you talked about, like treating it like there's like a in the lab time, like a childhood time, when you're in this safe space, you're in this, and you're going to train, and then we'll get thousands of copies or whatever, and we'll send machines out into the world. I think humans are doing this all throughout our life, so it's not. I don't think that what we're learning is the values. I think what we are learning is the cognitive process of reading values constantly from the environment and predicting how not the values, like not what should I put into my reward function, but now like what will be the consequences? How will people react? In a human, so people in cultural evolution, I think this is not the strongest theoretically, but it's where things are now. There's a view that humans have a preference for conformity, and so if you observe that this is how we all do things around here, they have a preference for conformity. I actually think that's actually just an implementation of, if I do it differently, I'm going to suffer some consequences. People are going to think I'm a weirdo, at least. But I think that's constant. So I don't want to disagree with you that there's a lot we could do with this kind of training, and there's a lot of human interaction. It takes a long time to train a human.
Sure, but I'm assuming you're going to do this in the real environment. That is to say, you're willing to accept the risk that the one robot you're training will at some point step on somebody.
Right.
Because after all, this is just one, and you're going to get 1 million later. So you have the robot in the environment, you have a human being monitoring, and maybe for some things you want to have the robot say when it'll do 5 seconds in advance, so you can tell it, no, you don't do that. But
right.
The simple model is just one where we want.
Yeah. Yeah, and I do think that there are people who are working on this, who are using techniques like this, human feedback and so on, in the lab, or like, maybe you've got your robot or your autonomous vehicle in a protected space, so there's limited capacity to do harm. But so I think I do think that's part of the process.
Well, I think that there's a missing distinction in the conversation. First of all, Gillian, I think this is a whole brilliant framework for thinking about these issues. So thank you very much for that. But your talk raises an incompleteness in two different places that I think are usefully kept distinct. One is, what's the extended meaning of the contract? When the contract was silent on something, and then the thing that's silent on becomes an issue. You talked about the institutional framework and the embedding in the systems of norms that is kind of the extended implicit contract that might turn into an explicit enforcement action by the framework in which the contract is being enforced. And I think this relates very much directly to the whole notion of split contracts and the kind of thing that Federico's doing, where you're bringing in this extended learned judgment system in the intermediary role of the extension of the contract. And then there's, separately from that, there's the issue of the impartial observer in the heads of the individual contracting parties as opposed to in the extended contract itself. And then and the issue about what would a participant in the contract, what would their own internal impartial observer, how would they judge their action? Part of that is inherently tied to their prediction of how would the extended contract or the system of norms of the society I'm embedded in view my activities. And the developmental account in theory of moral sentiments, I think, is very much that we abstract our own impartial observer, our impartial spectator, from learning how others react to us, that there's sort of this dual prediction going on there.
Yeah, so I agree with everything you said. So I'm not maybe I'm not seeing the tension because I guess I am. I mean, I'm waving my hand at the impartial spectator, Smith's idea, and saying that we do engage in this hypothetical process all the time. How would people respond? How would it? And the impartial part is to say, not somebody who, not an interested party, but rather somebody who's evaluating my behavior relative to the norms and rules of our society.
I think what I'm reacting is that the focus seems to have been on the extended judgment and learning of the participant of the contract, and without enough focus on the judgment on the part of the intermediary normative framework.
Right. Okay. No, that's really okay. So that's important in the sense of I mean, I'm sort of holding that the content of what gets filled in, right? What does the institution do? What are the norms? I'm treating that as the output of our normative system.
Okay. I think I can spot why there's this gap here, is that I'm looking at smart contracts. I'm looking at creating a whole new norm enforcing framework that is very much inspired by what's been working in human institutions, but is also to a large extent has to recreate and reinvent a lot of that on a more automated basis. So the fact that the contracts that we're writing in program code are incomplete is giving us novel problems that are different than the problems of the incompleteness of contracts in natural language adjudicated by humans.
Yes. No, and actually this is, so certainly in the domain of smart contracts, I think the message and what you're saying is, yes, the message needs to get here. Say, look, you think you could write down the auto-executing contract, but I guarantee you, this is for say I teach contracts, this is all we teach. I guarantee you there will be some circumstance where people will say, that's not what we meant. Right? That's not what we meant. And that's exactly why we have these elaborate institutions. And the institutions are not just adjudicators. They are also systems of reasoning and particular systems of reasoning. The particular system of reasoning and contract law in Anglo-American system, which is different from contract reasoning in, say, the French system or the German system. And it's that, I had a student who had a startup. I'm not exactly sure what happened to this sage-wise, but it was the idea of creating a platform that said, you're going to need you're going to need interpretation services and gap filling services for smart contracts. And so, so let's get creative. How do we do that? Right. We know that our existing institutions are quite broken. They don't deal with the human environment very well. They're too expensive. They're too slow. Most people don't rely on them. But we're going to need new processes to fill that in. So it's kind of related to Kate's question as well, I think, like how you can build that those new institutions that can hook into the smart contract. Yeah. Great.
Oh, let's unpack. Okay, we have Christine next.
So I'm going to challenge that. I think that first of all, I thought your presentation was great. And I thought that there was a lot of interesting stuff in there, especially around the stuff of that reasonableness that we can approach that in a smart contract system as we currently do. It was actually not until I heard about split contracts that I thought smart contracts were worth any attention to me whatsoever. So having reasonableness be something that's addressed is actually something I strongly agree with. But as in terms of having artificial intelligence systems be the arbitrator of reasonableness, in our contemporary systems, one of the things that's very important when a resolution is made by a judge is that the judge is able to explain why they came to a conclusion. And this is something that contemporary artificial intelligence systems are notoriously bad at. They're very black box. We make a decision based off of kind of absorbing a bunch of information from society, kind of like a gut decision type thing. And therefore, we also pull in like gut racism and gut misogyny and all that type of stuff, right? But one of the part of the directions that I find most promising in AI research are like propagators, and Leilani Gilpin's work on retroactively explaining why a machine learning system might have made a decision through propagators. Because if it seems to me that if I am going to trust any sort of AI system to step into making things reasonable, there's a phrase: an artificial intelligence system that can't explain why it made a decision isn't very intelligent. And so I wonder whether or not you think this is a prerequisite for further advancement in this area before we can trust AI agents to start making at least, let's say, criminal resolution level decisions in our society.
Great. Thanks, Christine. So actually, we're going to have to get Allison, you have to invite me back to talk about my most recent work, which is on justification, and is exactly on this point. And again, I think the AI world is barking up the wrong tree with explainable AI, because Christine, what you were saying about, like when the judge makes the decision, if the AI is going to make the decision and it's a black box, well, it's actually a black box with what's going on inside people's brains as well. And really, we don't want to know. We don't ask the judge to tell us, what neurons fired. It wouldn't help us to know that. We don't really even ask the judge and say, what really drove your decision, right? What we ask our judges to do is to provide justification for their decisions, which is to say, I can account for this decision with a set of reasons that are consistent with the rules and principles governing reason giving in this community. So I can't say I convicted that person because they were Black, right? I can say I convicted that person because I was convinced by the testimony that they actually were holding the gun, right? So, and we examine those decisions for whether or not those are accurate reasons. No. What was really going on is you convicted them because they were Black. We discipline our reasons, but it's that system of reason giving that is our control mechanism, and that's how we control decision making by human judges, is we expose that process. And I think that so I have a blog post on the website for my institute that talks a little bit about this, to say, and I'm working on a couple of different projects, to say we need to be thinking about how do we design structures where either humans can give justifications for the decisions. And we've been thinking about a licensing process for AIs that say you can't release a model until humans, given a test set, can predict what the model will do and give adequate justification for what the model will do. And then, can we even say you go back to that human and hold that human responsible? But I think that and there's also really cool stuff. I do want to come back and talk about what we found in some of our experiments on this stuff. But you're absolutely right that in order to build systems where AI is exercising judgment, it's filling in the contract, for example, or saying what's reasonable. We have to, again, hook that into our systems of normative control. And one of the key one of those is the provision and the scrutiny of reason
I just wanted
and
to
the
say that
testing of reason.
I agree with you. I'm not advocating for transparency of the execution process as a requirement here. So I
Yeah.
agree with the justification approach. Have you looked at Leilani Gilpin's work as in terms of creating retroactive research on this? She's one of Gerald Sussman's students. I
No,
put a link in the chat.
Oh, perfect.
She
I
has
haven't heard that. No.
she has an amazing system where she's hooked up propagators to the retroactive information of cars so that they can explain what happened that led to crashes or turning in this situation and blah blah blah. They can retroactively construct what happened, much like, as you said, a judge might not be exposing their entire firing of neurons, but they will be retroactively thinking about the conclusion they came to and walking backwards from there to understand why they ended up coming to this conclusion, basically.
Yeah, I thank you for putting the link in. I'll go take a look. I do want to emphasize the key distinction between the causal account of how a decision was reached and the normative justification for the decision. And those are two different things. And there's lots of good reasons to want causal accounts, like, oh, we got to fix the machine. It's responding to the wrong thing. It's seeing snow. It's not seeing dogs and wolves, right? It's seeing snow. We definitely do want explanations. And anyway, I'll look that up. That's great. Thanks for the link.